Welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. Okay, last session we have implemented this get context type function, and it looks promising, but of course there can always be edge cases that maybe I am not quite considering right now, but let's hook it up. So so function, yeah, I would say we remove this condition here. I mean, it is a nice shortcut, but so I would say we do get context name, no, get context type. There we go. That one takes a name. Hold on. Name. String view has data. Name. Name. Can we make this take a string view? Type equals name. Yeah. This function argument, yeah. I think we can change this to string view as well. String view name. String view name. And and then we can get context type. We can, I think, also make this take a string view, if I'm not mistaken. Name. Yeah, that looks good. Okay, so get context type, and we pass function deckel context name. Yeah, and we say std string. No, it returns context type flags. Context type flags. Context type. And we can make it const. And so we say build class or namespace from function context. I think the expectation is here that it is asserts, it cannot be an enum, right? So the assumption here is that this is context type, so it must be a class or context type namespace, right? Context namespace is not 0, right? Yeah, it's one of these two, and so we say if it is if it So down here, if it is a name, I don't want to put everything into classes, but okay, for starters, how about we say if context type is class, then we do this. Let's put a breakpoint here. What we do? If we say if it's not namespace, if namespace equals 0, let's say a bool is const bool is namespace let's say is expected namespace. It's not 0. So if not expected namespace, then we create a class, and otherwise we create a namespace. I think that is a fair assumption. So here we also have find or create class by name. Find or create class. So the parent name, a class parent cannot be an enum. So here's a similar story. Context type parent name. Yeah. So this one is also expected to be a class or a namespace. And then we do the same thing here. If not expected namespace, then it's not, it is expected namespace. Not expected. Let's copy this thing. Okay, what do we have here? We have the same story again. Context name, variable, decal context. Yeah. Let's also put a breakpoint here. And then take another one. Man, so many. But this one we have not yet implemented correctly. Let's comment this out for now. Yeah, okay, so breakpoint there, and breakpoint here. I just like to see like what namespaces we're getting. Let's also, we also need to implement this function here, is template argument. So we need to go through all functions and all variables. Type function dot m dot here, these three. Strictly speaking, we would also have to check the return type is function argument. Return type of a function. Yeah. Okay, so parameter template types. Yeah. Mm-hmm. One, two, and so we do parameter template types, function template types, and this one. If type matches this, then return true, otherwise false. Yeah. It's template arguments. I think that's it. No, hold on. We are missing for const variable, variables, and oh boy, this is expensive, isn't it? For variable, I think context template type names. Yeah. Can we simplify this? I think that's good enough. Yeah. There's probably a std function that you could use here, but then we have to use a lambda function, and lambda is always I'm not super big fan of lambdas. If they can be avoided, it's better to just write this simple code here with loops, right? Which is typically good enough. What we could do maybe is make this even more less scopes here, like that. Oops. Yeah, I think that's good enough. Yeah. Is template argument. Okay, so we got that implemented as well. Let's put a breakpoint here. We have here breakpoint there. Is templated context name. Let's put a breakpoint there. That's a new check as well. Let's put a breakpoint here. This one we already know works. Is known class. I think this is also a new check in here. This one we already had before. Yeah, I think these are all new tests we put in there. Then let's see what happens if we hit any asserts. Yeah. Hopefully it's all good. Yeah. Oh, well, that's that's unexpected. Okay. Oh. Right. Get context name. So it can be empty. But hold on. But this one has passed here. Has context name. Oh. Right. We should test this function here as well. Looks like, yeah, let's put a breakpoint up here. Okay, so this is incorrect. How should it be then? So name with context. Yeah, right. Must +2. Right. Yeah. So it must be larger than name without the context +2 because of, let's say, plus, it's +2 for this. -2 for this. Right, so this, yeah. Maybe we put here a namespace, const expr, static const expr, double colon len is 2, size t. Let's give it a name. Then I think that's more clear then, and we don't need the comment. Okay, let's try this again. Yeah. Yeah. Okay. So class name is std, context name is empty, context name is templated. Oh, but then this will crash, right? Because it's 0. Haha. Context name. Yeah. Get context name. Hold on. Get context name. Has context name. Has context name. Yeah. Parent is class or namespace. Yeah, returning. Maybe we should. Maybe we should assert his context name and do this, and then we do this one is okay, and this as well, and then here we do so this is all context name. If has context name name class name is templated is known class. So we put these guys in here as context name. And then we move this one down here, context name. Let's allocate the string right away. Let's not make it too complicated. Context name here, boom, boom, boom. And then we remove this one here, keep it simple, right? Like that. Context name, okay. Okay, then put a breakpoint here and here. Oh, let's put a breakpoint here. Many breakpoints. Let's try this again. Oops. All right. Good. So class name std name std class name. Get class name. You know, get class name without context name. Actually, and I'm thinking about it again. I think the way we had it before was actually makes sense. We return an empty string this way, and then what we do is so here we do this, and then we can say if context name not empty. Yeah, I think this makes a bit more sense, right? Then we don't need to like separately call this has context name function. I think this is a bit more elegant. Yeah. Maybe we should also do it at the other places here. So we can do const std string view context name equals that thing, and then if context name not empty, then we go in there and then we assign this to that, right? And then we do the same here. Std string view context name const equal get context name there, name class name daram context name empty, not empty, context name, and then here parent name, context name. Yeah. I think that makes sense. Let's try it again. Okay, so so name and class name, context name is empty. Yeah. Is function argument? No. Is template argument? No. Is typical namespace name? Yes. STD is typical namespace name. And so assert is expected namespace, true, and boom, we create a namespace. Excellent. Okay, let's see the next thing. Let's put also a breakpoint here. Yeah. Okay, let's see what we're getting here. Okay, boom, we got here. What do we have? Class name, Mac tools. Well, this one is actually the namespace likely, right? But yeah, since we have this, so now it doesn't. Yeah, but that's fair. We don't know if it is a namespace. So we end up down here, and then what we do is is expected namespace, and we still go down here. Yeah. Okay, let's see. Here we have template. Yep, this is definitely a class. This one is a namespace again. Let's remove this one here. Okay. Build class from function context. Process symbol. Okay, so here we have another Mac folders. This one is template, yeah. STD, yeah. Another template. STD, Mac files, Mac builder, Mac memory, Mac globals, Mac debug, Mac log file, vector. Okay, so I think this one works pretty well. This one also works pretty well. Mac strings, var buffer. Okay, so var buffer could be all of these three. Yeah, could be a namespace, could be an enum, could be a class. It's probably a class. I would say it's probably a class. So it is never used as a template argument. Okay. Surprise. Okay, is typical class name C open GL matrix. Yeah. This looks like a class to me. This also looks like a class. This too. What do we have here? GNU. Another one. Aha, it's function argument. Matrix ready. Matrix ready. Yeah, so it is a class. It is a class. Yeah. So is there ever a time where we then create an enum? I don't think so. We never will create an enum. We'll either treat it as a namespace or as a class, right? We never say it's an enum. But we will comment them. Everything that could be an enum, we will comment. Same with the other things. Yeah. We still need to also track this. Yeah, I forgot that. We need to track that. Yeah. Okay, is function argument, yeah, matrix ready. Matrix ready. Matrix ready. Matrix ready. Yeah, so then what happens? It goes down here. Is expected namespace false, so we will create a class. That's fair. Okay, multi any field pass is also function argument. Yeah. Is typical namespace name. Okay, interestingly, GNU CXX is not recognized as namespace name because because of the underscore symbol. It's slower. Yeah. Yeah, maybe we should do it differently then. Maybe we should say for char C in namespace name. Actually, it doesn't work. Actually, does it work? Yeah, it has a range. So if we just say if it has an upper space character, if std is upper C, then return false. Otherwise, we say return true. Is upper. std. What was the name? Copy value. Yeah. Okay. Then looks like we don't need this function anymore. Can comment it out again. It's slower. Then we remove this. So if the char is upper, C, char C. Oh, this one is incorrect now. Hold on. This one is violating the contract of std string. Yeah, I think previously we had a std string and then it was okay, but this is now not okay. We cannot check for null terminator here. Then we should also we need to check if not empty, or let me say if empty return false. Or maybe we should assert not enum name dot empty. Not namespace name empty. Not class name empty. And so here we need to check 0 construct. Let's do for size t I equals 2, I smaller than enum name dot size plus I, and then enum name is lower I, and then we can remove all this here. There we go. Is upper. I think we need to say here we should probably the enum name dot size should probably be larger equal 3. Yeah. And we should do the same here. Class name dot size larger equal 3. And let's make a new condition. Let's build a nice letter here. If E, there we go. A beautiful letter. And then we do put this in the letter as well here. Beautiful. There we go. And then we take this guy here and we put that here. I to class name size I, and then class name I true. Okay, but now since we have this check here, we don't need the assert anymore. It would now work without it. Yeah, we can move it again. Okay. Okay, I think this looks good. It looks pleasant on the eyes, right? Yeah. Okay, let's try this again. Yeah. So basically we go here. So this should now hit on GNU CXX std Mac tools std Mac preferences std Mac files Mac builder Mac globals Mac Big Mac std, a lot of stds here. Mac strings, var buffer, c OpenGL, c TextStage, yeah. std, c text unit, std. Yeah, there we go. That looks good. Okay, then this one seems to be fine. Then let's do this. Matrix 3D. Okay, this looks good. Save date is also a function argument. Armor template set. CRC. CRC, yeah, could be a namespace, could be a class, could be an enum. Could it be? Well, if it doesn't have any context from function context. Well, it can't be an enum here in this case, but we only know this high up. Yeah. Only know this high up. Okay. Oh, what do we have here? Dict is known class. What is this? Name? Dict pair. Okay, so we know dict is a class, and that's how we know the dict pair can only be a class or an enum. Yeah, it's not a namespace. Okay, that's good. That's a good check. We didn't have this before. This check. Yeah. Okay. What do we have here? Static name key. This is probably an enum, right? Well, who knows? Could be something else. Could be a class. Yeah. Could be a class or a namespace, I think. Yeah. This function argument. There's one more thing. Hold on. If this name here contains functions, then we know it's not an enum, right? So I think we are missing a check here. Yeah. So we need to look. We already have this here, has CTOR or DTOR. So we need to have another check, has function, or owns function, has function, contains function, contains function. Yeah. Then we know it's not an enum. Contains function. Contains function. Contains function. Contains function. I realize that can even narrow down this more, these checks. If we know that it contains a function and then we combine it with one of these informations, we can get even better quality because then we can eliminate the enum guess, right? Yeah. Then we can eliminate the enum guess. Yeah. But that needs extra care then. Basically, we would need to change the function then. Okay, I mean the first three are okay, the first three conditions, but then it's typical enum name. So basically, it's templated. It's templated. So if it contains function, then we know it is. Oh shit. Contains. Okay, so I think we need a check here. Let's rename. Let's first stop debugging. This one here has contains, or has is okay. Has Citor, Detour. Yeah, let's just create a bool has function, okay? std string view class name, yeah, const has function. Good. Then do we already have a function with this kind of name? No. Good. Then here we create this and that. So basically we need to check if has function. How about we combine it with this one? Has yeah. Yeah, maybe it's better we so we don't have to look through the functions twice. So this is expensive. Yeah. So how about we create a struct. Enum, no, struct class function info. So all we need to know is un16t function count, un16t detour or citor or detour counts. Right, 0, 0. Class function info. So we say this get class function info. Okay. Then we put that here, here, here. Then we create that info, return info, and then we move this here, and then we go through all this, and then we go but the disadvantage is we need to go, yeah, definitely always through everything. Of info. So if deckel context name is class name, and citor function count citor yeah, let's say if function, if this function then info dot citor dot count plus plus else plus plus info dot function count. How about we remove this here, this, okay. Do we want to break early? I mean, technically for our needs, as soon as we have this, we could break, technically. Yeah. Yeah, but then it would be better to say, okay, has citor or ditor or has function. All right. Maybe it shouldn't be get context function info name. Context function info. Context function info name. Because it can be in a namespace or it can be in a class, right? Info. I think maybe it's, I mean, for our purposes currently, it would be enough to just have two bools here. One bool has functions, has citor. Yeah, I think this would be has bool has citor or ditor, false, or bool. If we need a count, we can then change it another time, right? Or has function, has citor or ditor, or has other function. False. Has What about virtual functions? Hold on. Do we save in a function if it's a virtual one? Yeah, okay, but if it's a virtual one, then we have vtables, right? Yeah. Yeah, I think that's, yeah. Yeah. So I would say we do you know what? I think the count thing was fine. Let's do the count thingy. Function count. Other function count 0. Other function counts. So if function decker context is this, okay, and return info. Okay, this makes the whole exercise a bit more expensive because now it really needs to go through all functions. But okay, so we call this name. Let me say context function info. Function info. Make a const. And function info. So if c2d count is larger than 0, then it is a class. Otherwise, if it is a, so if function dot other function count is larger than 0, then we know it's definitely not an enumeration type, right? So this can't be true. This, how do we code that? I could probably like subtract it again. I have an idea. We can, we put a, oh boy. This is really expensive, this function here. But it's okay. As long as it gets us good Intel, then I think that's good. And with Intel, I don't mean Intel CPU. Right? Bad pun. Good. So I think what we should do is enum context equals this one, yeah, and then we say if enum context, so if the other function count is larger than 0, then we know it's not an enum, but we cannot tell yet if it is a namespace or a class, right? So, but we can say it is not an enum, right? So we say enum context equals none, right? Let's put the expensive one here. Has constructor or destructor. Class has this. Okay. Enum enum context. How about we write this differently? We say that the typical flag removal enum has no functions. Enum has no functions. Yeah. Okay, and then we use this here. If enum context has this flag, then we will check for this. And then we also put here enum context, enum context, enum context, enum context, enum context. Yeah. So it is now possible to exclude enum context from the whole logic. And that's cool because if we find a function in here, and then if we hit one of these conditions down here, then we will know it is a class and not a namespace. So that's cool. So we should be able to get better results in some scenarios, right? Yeah. Let's test that bitch. Excuse my language. Right, enum. All right. Okay, so we got such a hit here. Okay, that's cool. So the constructor count is 0, but we have 38 other functions. So the enum context will be set to 0. Yeah. Then is typical class name. It's std. Okay, well we know that this is a namespace. I see. Yeah. Well, 29. What is this? Mac tools. 29. Mac tools contains. Okay. Yeah. It can be a class or a namespace. Yeah. Okay. Well, let's put a breakpoint. Well, we have breakpoints here. Here. Yeah, we have breakpoints everywhere. Okay. Good. So what do we have? Class name, Mac tools. So we know it's not an enum. So it's either a namespace or a class. Yeah. Namespace or class. That's good. Let's put a breakpoint here for condition enum context is not 0. Okay, what do we have here? Okay, we have a class. Fair. Here we have another class. Okay, what do we have here? Enum context is 0. Aha! Look at that. So with the matrix 3D now, we know that this is not an enum. So now we can correctly classify this as class. Amazing, man. Big brains here, really. Massive brains here on YouTube. Wow. Man, this function is so complicated. My gosh. To correctly classify this is a nightmare. But I think we are already on a good track here. This looks solid. Yeah, there are probably some more conditions we could fit in here. Who knows? Yeah, there could be some more. Yeah, I mean, we have a lot of data to work with, right? So, yeah. Good. So matrix 3D. So this will be classified as a class. Yeah. Let's see. Here we have multi-ini field parse, and that is also a class. And save date, also a class. Armor template set, also a class. Dict pair, dict enum context is also 0, so we know that this is also a class. Amazing. We're really eliminating here false positives. That is great. Great. Enum context. Okay, what do we have here? Name, parse find cell info. Parse find cell info. Parse find cell info is function argument. No enum context, so we know it is a class. That's amazing. That is amazing. Yeah. Okay, let's look at some more. Object creation lists. Yeah, partition contact list, 0. Weapon bonus. Weapon template set, amazing. So we're getting really clean results here right now. I really like this. Deliver payload data is a function argument. Yeah. Train track. Nice. Railroad behavior. Also clean class classification. Clip poly class. Typical class. Oh, this one is okay. This one is unexpected because it's not a typical class name. Because the second character should have been upper. What is wrong here? Let's move this here. Class. Let's see. Let's step in there. Oh, it ends with class. Yeah. Okay, I'm retarded. Yeah. That's definitely class. And yeah. Good. Is known class, model condition info. So we know it is a class. What is it? Name. Weapon barrel info. Name. Matrix 4x4. Contains functions. Is not an enum. Animated sound manager class. Is typical class name. Bitmap handler class. Dazzle ini class. Dazzle visibility class. Decal poly class. Okay, let's remove this breakpoint here. No longer interested in that. Quaternion. Quaternion certainly is a class. It's not an enum. Very nice. ASCII comparator. ASCII comparator. Enum context 0. ASCII comparator. And here we have an enum context. Look at that. What is it? Music track. Ooh. So music track, it contains no functions, nothing. So it could be a namespace. What is in there then? Ah, maybe some variables. Yeah. Ah, hold on. If it... Aha, hold on. There's another condition we can put here. We should also check variable info, right? If there is a variable, inside the context, then we know also that it's not an enum because a variable cannot be inside an enum. Then we also know it's not an enum. Okay, then we need to add that as well. We're really making progress here. Expensive. Let's put this comment here because it's this function that is expensive, not this statement here. Expensive. So I would say we function info. Okay, where would that check be then? Well, it would be right after here, right? Yeah. So basically we would have context struct context variable info variable count. Okay, and then we would say, oh, my hand hurts. Here context variable info get context variable info. Okay, I wonder if we can optimize this stuff here, but because this lookup is really expensive. I mean, we could cache it, pre-compute it maybe for all, but maybe that's even more expensive. Yeah, I don't know. Okay, so I would have here context variable info variable function variables variable deckel context name equals name, then plus info dot variable count. So, we also go through the whole thing. Yeah, we want it to be expensive. It's okay, whatever. Who cares? Who cares? Make it expensive. Okay, so how about we put this guy here? So this will be variable info, and we call it variable info, variable info, get context variable info, variable info, and then, so basically we say here else if, hold on, we can optimize this a bit. We say else, let's make this, we can put this in here in the scope, and then we say here if enum context info function info expensive else function. I think we can also put this in a scope, and we say else if variable info dot variable count is larger than 0, then we put the enum has no variables. Yeah. This one. Yeah. Ah, hold on. Enum context needs to go. Enum context needs to go. Enum context function info. Enum context needs to be here. Enum context. I don't like it. Let's put it back. Enum context. Here, enum context. Da, 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 da. Let's put here space variable for actually. Let's make it a bit tighter here actually. Okay, this looks good. So basically now, if there is a variable inside, let's put a breakpoint here. Let's see if that's getting hit. Probably. Okay, so variable info. Aha, there we go. See, it contains GNU CXX contains a variable, so we know it is not an enum. Oh, but this will be expensive because this GNU CXX, this comes in here a million times. Oh boy, this will balloon the cost. This will balloon the cost. Oh boy, it will go through all functions, all variables. Okay, but I think this one is more expensive because yeah, there are way more functions than there are variables. Yeah. Okay. Okay, but this way, at least the cache probably remains hot here with all this looking up. Well, I don't know about the lower level caches, but those closer to the RAM, I don't know. Actually, there's probably a lot of data that gets pulled through it. There's probably a lot of purging of the cache. Yeah, I mean, how big is cache? Level 3, I think 32 megabyte roundabout. Was it larger? 32. The next one, level 2, 2 megabyte. And level 1 around 64 kilobytes, something like this. Yeah, it's not very large. I mean, 32 megabyte. 32 megabyte probably fits a lot here of what we're doing. 2 megabytes, oof. Probably not. I mean, hold on. Function. Let me see if we go through the function. I think the functions were around function. I cannot see right now. Hold on. 520 bytes is right now, right? So if we go to the calculator, what was it? 520? 520, and we have around 20,000 functions in there, right? So times 20,000. So that is 10 million bytes. So that is divided by 1024. That's kilobytes divided by 1024. That is megabytes. So 10 megabytes is functions. Yeah, I mean, in release is probably a bit smaller because vector and string, I think they're larger here in debug. Here, this one, I think a string actually should be only 24 bytes. I think string is 24 bytes in release. So in release, I expect this function to be much smaller. Okay, well, it probably fits here into level 3 cache, but level 2, yeah, probably not. So this is expensive here. A lot of loading, yeah. But I think we don't care. I think running it in debug will probably be reasonably fast. Yeah. Okay, let's see what we got here now. What do we got? Okay, so variable info, blah, 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 context name, function, and it is a namespace, yes. Yes, 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 good. Why is it, hold on, why is it parent name? Oh, I just realized we have no check here for is known. We already know this thing. So we could actually save here. We're doing more work than we need to. Um, variable. So this one adds it to class indices, class function variable. So hold on. Name to class index. Name to class index. Find out create class by name. Okay, so I think what we should do is we should do this. I think we can remove this here. Yeah. Okay, so I think what we need to do here is parent name. Take a context. Context parent. Take a context name. Oh shit. What did we make wrong? What did we do wrong? Else? There needs to be another. There we go. How about we put this into a new function here? It's getting quite big. So we have a parent name. That's a decal name. What would you need to pass there? The parent name and the class index. Class index. Class index. Yeah, how about we find or create class by name. Function context. How about we create a function, build class or namespace from class context. Which looks very familiar to what else we have here. So that will be MachOCodeGen. So how about so this here, and then we call build from class context, and we give it the class index. Class index. And let's take this and comment this out. Let's go in there. Class index. And we put this in there. Okay, so we're missing parent name. Yeah. So, I mean, I think it would be nice if we would do it similar to this, but here we can't do that. We can't do that. We need to do. So it's parent name. Where's it? Parent name. So basically, as soon as we call this, any reference to the class instance for class index, if we would have taken it here, could be invalidated if the classes container reallocates within this call, right? So that's a danger, right? So I think what we should do is mClasses class index dot decal context name. Yeah, it's quite a bit. It's quite a bit of mouthful here to put it here, but maybe that's fine. But I mean, we don't really. How about we say? Std string decal context name class decal context name. We make it a const. Okay, but it might be invalidated later, right? So we need to be careful. That we should create a comment here. Do not use after here. Yeah, we absolutely need to do not use this. Okay, so we have that. So take a context name. I think we can assert that this one is not empty. I think we expect that this is not empty, but we also need to set it. We set it after we call this function actually, so we need to set it before. Okay, so we put this one here, and get context type here, and here, and here. Okay, that looks good. That looks very good. And how about we move these two up here so that we can group the other three together. So we take this guy and we move it up here. There we go. And now we have all three together. Look at that. They all look very similar, but they do slightly different things, right? We also still need to do this here. Yeah. Hold on. Something. We need to move these two up here. There we go. Oh man. So is maybe class, yeah. Okay, this looks good. And then let's go where this is called. Let's leave this commented code here in for now, but I think this will work. Yeah. Okay, this should be good. Why we are at it, so is maybe namespace is maybe enum. Namespace is maybe class. It's maybe class. And this one is also maybe class. Maybe a class instead. This enum was guessed. This namespace was guessed and maybe a class instead. Yeah, it's maybe class. It's maybe class. Can a namespace be an enum? Yes, I think so. It's maybe class, it's maybe enum. Yeah, all three types can be true at the same time. So I see. So we should have here bool m is maybe namespace false. This enum was guessed and maybe a namespace instead. I don't think we actually will use it. So that might be false always, but let's have it here for now. I think that's good enough. And this one, bool, same thing, right? Bool m is maybe enum false. Yeah. This namespace was guessed and maybe a enum, maybe an enum. Yeah, is maybe enum. Maybe an enum instead. Yeah. Good. And then so what we should do is, oh, my hands. Let's see here. It's names. It's not class. It's not namespace. Non enum. Not is non enum. Build class or namespace from class context. Yeah. Okay. So basically here we need to say namespace in the example class. Classes if so wait. So if context type is context type enum, then we say I think we can simplify this like this, right? Classes, context type, enum. No? What is the complaint here? Oh, right. M is maybe enum. There we go. Okay, and then is maybe namespace. That is where we only enter here if it's not namespace. So we never set. We never. Yeah, let's for completeness sake, let's put here anyway. Is maybe namespace, right? I think this is always false, but for code completeness, I think we could put it here. And here we would say context type is maybe it's also class, right? No, hold on, namespace. I created a new namespace. So namespace index. So that is maybe class, and then here class. There we go, and we put it here, and then we remove this one here. Good. So we need to put this here as well, and here as well. A lot of copy pasting, and then we take this here. How about child class? No, that's fine. So we take this guy and we put that. Push back. Class index. Classes, class index. Right. Function indices. Right. Okay, so this one also goes here. Yeah. Okay, I think this is correct now. Yeah, maybe. Hopefully. Maybe not. Maybe enum, maybe class. Yeah. I have the impression that this shouldn't be. Maybe we should store just a context type in there. Yeah, maybe. Yeah, how about we store the context type in there? Which also gives us additional information, because then we know it was a generated class, right? Yeah, maybe we should do this context type. Get context type tickle. How about we rename this to candidate type flags, and this one to candidate type flags as well. Then we rename this one candidate. This one candidate. Man, I'm really in a good flow right now. Candidate. Candidates. Do we have some reds now? No? Okay. So this is currently in the MachO reader, but maybe we should context type. Yeah, so how about we take these flags and we move them here, up here. Put them here. And maybe we should put the forward declarations higher up. I think it's fine here. Okay. Yeah, so maybe we should put the candidate type flags here. Candidate type flags. Candidate type flags equals none. This namespace was guessed and maybe another type instead. Okay, that's a bit too long of a comment. Let's put it up here. Okay, so I think we can then remove these. And then we can create a function here, bool is generated type const. Actually, this is not a useful information, but we can say is maybe enum candidate flags type return candidate flags enum, yeah, is maybe enum, is maybe class, yeah. I think that's a better implementation. Yeah. Okay. Okay, let's take this. And so here we have variable class. Well, looks like we don't need this to be, well, we can put this back, this, Class, how big is it now? Oh, fits right in there. Okay. Okay, size. This namespace was guessed. This class was guessed and maybe another type. Well, that comment is a bit stupid, isn't it? This namespace, candidate type flags. If set, then this namespace was guessed. Yeah, okay. Class, then this class. Okay, and where is enum? Enum, hello? Enum, here. There we go. Oh. There we go. Then this enum was guessed. Let's remove this. And candidate type flags. I think we can. Oh, hold on. We have an error here. Class. Okay. Enum is maybe namespace. Namespace. Okay. Candidate flags. Namespace. Okay. And class. Namespace and enum is maybe enum. There we go. Good. Okay, and then here we say get context candidate type flags. Oh, this is no longer part of that. Okay, and CPP types. We now need to go to here where the red stuff is here, and I think we simply now need to just assign the classes. I think else. I think it's simply m classes dot candidate type flags context type. There we go. And then we can remove all this garbage here. Yeah. Okay, put that here. Oops. What do we have here? Class index. Okay, hold on. Oh. This belongs here to this one, right? Maybe we should put it up here. Candidate type flags. And we would put the same here. Namespaces dot candidate flags. Oh my gosh. Equals context name. Oh my god, I write cons. Let's just copy this. Copy. Okay, belongs here and here. Okay. There we go. Okay. I realized that we misspelled this one. It should be called M candidate type flags. M candidate type flags. Okay. And the enum. Yeah. All right, there we go. Okay, I think we still have one mistake. I forgot something in here, and that is this one. This one needs to happen before we call this. Yeah, why do we? Oh, I think what we can do is, yeah, why do we assign it here, parent name? It's so late. Can't we just put it up here? Class, parent name, context name. Yeah, how about we assign it here, this context name? Then we don't need this. And then we essentially need to pass this here. I should do. Fine. Okay, I think this is good. If we didn't make a mistake, then it should work, but we probably made a mistake somewhere. Right, it's very possible. Let's see what happens. Okay, what do we have here? Name. Okay, next one is matrix 3D. Yeah. Okay, save date. More template sets. Looks good. What do we have here? Dict. Name, pass, find, cell info, object creation list, partition contact list, weapon bonus, weapon template set, deliver payload, train track, railroad behavior, snow class, a context name. name matrix 4 by 4 quaternion. Cfence contains one variable, so we know it is not an enum. That's nice. Right. Well, now we would figure out that it starts with a C, so we know it's a class anyway. Yeah. Yeah. But I think if some of the others would have also passed then, yeah. But good enough. Good enough. Okay, let's see some others. Music track. This one contains variables, so we know it is set. It has not a typical class name. We have no context name. It is not a function argument. It is not a template argument. It is not a typical thingy. Okay, so this could be either a namespace or a class. Okay. What do we have here? Music track. Namespace index. Yeah. Name. Map meta. Okay. Map metadata reader. We know it is not an enum. So it's either a namespace or a class. Yeah. Put a breakpoint here. Anonymous namespace. What about this one? Oof. We don't want to create a class for that, right? Hold on. Anonymous namespace. Didn't we anonymous? We did something about it today, no? Find or create namespace is anonymous. We didn't create it yet. Okay, so what do we do now? I guess, well, if it has this name, then we should probably yeah, if it has this name, yeah, let's say expensive. It's templated. If class name is anonymous namespace, then return candidate type namespace. Right. Okay, let's try this again. Let's put a breakpoint here. Okay, so we have seen this working, so let's remove this breakpoint. We have never seen this one hit. Yeah. Function argument name. Okay, we have seen this. This looks good. This one looks also good. ASCII comparator is template argument. Yeah, okay, that's also good. We have this anonymous namespace, and that will context type deckel will create a namespace. Yeah. Okay, that is completed without any errors. I wonder if we still have some errors somewhere. It's possible. Let's go to our watch. This. We have some less namespaces now. I think previously we had. I think we had the same 42 or something, 41. Yeah, nothing has changed here. We have anonymous. Texture loader. I think that's a class, but we don't know. So it can be a class or a namespace. So this one will say 5. That's 1 plus 4. Yeah. 1 and 4. Yeah. I think many of these are 5. Yeah. Apart from a few, like I guess STD. That's 1. This one should be a 1. Yeah. CSC. That's a 5. It's fair. Yeah. Basically RTS. That is probably a 1. Yeah. So basically, all these we will classify. We will make a comment that it could also be a class. Yeah, could be class or namespace. Okay, I think that's fair. Okay, we have enum3 classes 2, 1, 3, 3. We have a few more classes. I think previously we had 2,115, and now we have just a few more. So I guess. Yeah. Just a few more. But we don't have the. Wait. We have implementation for this, right? We have implemented this. No, we have not yet. Yeah. Okay. When we implement this, maybe we will get more classes from, what is it? Function arguments and from function arguments. From function arguments, from variable arguments. What about templates? I think it's included in here, no? Function arguments. Anyway, we need to build it from arguments and from template arguments. Yeah. Contexts, arguments. Yeah, I think we just make it both. Let's move this up here. Variable arguments, function arguments. Yeah, what about class arguments? Well, class arguments are already part of function arguments because it contains. We don't need class arguments. We don't need class arguments. Maybe we add a comment. Function arguments contains class templates arguments as well. It generates builds types from parameter lists and template arguments. Maybe from function parameter, what function arguments, lists, and template arguments, lists, function argument lists, and class, comma, function, template argument lists from variable arguments. Yeah. Function. Yeah, I think maybe we should do it differently. Maybe we should have function arguments and class arguments, because the function, yeah, so to do maybe use template arguments in function instead of in class, instead of function plus variable. Because the thing is, if variables and functions, they probably both have the same context, right? So if function is inside a template class and the variables inside a template class, and then they have the same context, right? So there will be overlaps between function and variables. But if we just do function arguments, function template, and class template, then variable is implicit in this, right? Because and function implicit as well, because function contains that context, that class, and variable as well, the same class or other classes, right? So maybe that would be better. So we have class arguments and function arguments instead of variable arguments, which are also confusing. Yeah, it's also confusing. Yeah, I think that would be better from functional. Yeah. Okay, good. Yeah, then we continue with that in the next session. I think for now, we have this session, we have made quite some progress. Yeah, we have made quite some progress, and I'm very happy with this function we have now. Somewhere, this one here. There's a lot of logic in here, which helps building the thing. Yeah. Good. Yeah, then I will take a break here. 2 hours 10 was a good session. I wish you a great day or night. Until next time. Goodbye.